What you're about to watch is a video clip taken from a Yaskawa Electric America e-learning module. While this video clip is informative, it does not provide the interactivity that is normally found in a Yaskawa e-learning module. If you wish to download a copy of this interactive e-learning module, please go to www.yaskawa.com and click on the tab labeled Training, and then either Drives Training or Servo and Motion Training. Thank you.
Welcome to the eLearning module, MP2000 Hardware Specifications. My name is Matt Pelletier, Product Training Engineer for Yaskawa Motion Control and Servo Products. I'll be your instructor for this e-learning module. Axes of control can be expanded using motion modules. There are three types of motion modules available. The most common is the Mechatrolink Master. It controls networked amplifiers by commanding position, speed, or torque over the network. The analog motion module positions the servo by sending an analog speed command and reading encoder feedback. The third type of motion module is the pulse output module. This module is designed to control steppers or servos with step and direction input. First, let's look at the specifications of the Mechatrolink Master. Additional Mechatrolink Masters can be added to the system if the application requires more than 16 axes. The Mechatrolink Master runs either a Mechatrolink 1 or Mechatrolink 2 network. All Sigma Series amplifiers offer options for integrating with the Mechatrolink network. Network I/O can also be connected. The Mechatrolink Master commands position, speed, torque, or phase. At 2 milliseconds update, the Mechatrolink Master controls up to 16 axes with a total of 20 slave nodes of motion and I/O. This means the maximum number of axes possible in an MP2300 system comes to 48, 16 built-in, communication module in one slot, and Mechatrolink Masters in the remaining 2 slots with 16 axes each. The maximum number of Mechatrolink Masters in an MP2200 system is not based on the number of slots, but rather is set at 16. 16 Mechatrolink Masters controlling 16 axes each produces 256 total axes possible. The Mechatrolink 2 system benefits from a substantial performance advantage because the backplane and network are synchronized. Network axes, network I/O, local I/O, and the ladder program all work together in perfect synchronization. Synchronized performance ensures perfectly coordinated motion, especially for applications with high speed and high axis count. The MP2000 controllers are compatible with any third-party servo or variable frequency drive by using an SVA01 analog motion module. The SVA01 provides 2 axes of servo control for systems programmed with MotionWorks. The modes are open loop speed, open loop torque, and phase. The SVA01 accomplishes closed loop positioning by sending a speed command to a servo amplifier running in speed mode. Phase control method sends a corrective position while commanding speed, ensuring that the axis remains in phase. Closed loop positioning is not possible with torque mode amplifiers with the analog motion module. Torque mode in the MP2000 controllers is designed to be used only when the motor should follow open loop torque profile. The SVA01 analog motion module does not use a position loop to generate a torque command. A pulse output motion module can be used to control 4 axes of motion. This is useful when integrating steppers or servos with pulse input. I/O can be expanded beyond the capacity of LIO option modules installed in the base unit. Available Mechatrolink 2 modules are a 64-point I/O unit with syncing outputs, a 4-channel ± 10-volt DC analog input, and a 2-channel ± 10-volt DC analog output, a 2-channel reversible counter, and a 2-channel pulse output module. Each Mechatrolink network can support up to 20 I/O modules. Mechatrolink I/O modules enable the MP2000 series controllers to integrate thousands of I/O points. This table summarizes the hardware available for the MP2300 and MP2200. The MP2300 base unit can control up to 16 axes with the built-in Mechatrolink Master. One of the 4 available communication modules is always required. The MP2200 base unit always requires the CPU module, and multiple base units can be chained together using the Extended I/O Interface Rack extension module. Onboard I/O is expanded with the I/O modules. 3 different types of motion modules with the MP2000 controllers compatible with all types of servo and stepper axes. And the Mechatrolling 2 modules make it possible to expand I/O even further. For even more remote I/O options, Phoenix Contact, in a joint project with Yaskawa Electric America, has developed a Mechatrolling 2 bus coupler. This unit is available through both Phoenix and Yaskawa distribution. The bus coupler includes 8 digital inputs and 4 digital outputs. Input and output capability can be expanded by adding modular slices to the unit according to application requirements. These slices include additional digital and analog I/O, as well as relays, temperature controls, RTDs, thermocouples, and PWM outputs. In order to determine the components necessary to build an MP2000 system, the application requirements must be distilled into 3 categories. These categories closely follow the hardware categories that have been discussed. Let's consider an example application. First, what network communication or connectivity is required? In this example, let's assume Ethernet communication is desired. Second, how many axes are required and of what type? In this example, we require 8 Mechatrolling 2 servo axes, but there are 2 existing servos with speed demand input that the customer also wants to use. The third question is how many input and output points are required and of what type. This example application requires 150 digital inputs and outputs, as well as 2 analog outputs to drive inverters. So, what hardware will be required? This application can be solved using the MP2300. In addition to the base unit, a communication module is always required. So for Ethernet connectivity, the Ethernet communication module 218IF01 will be used. No other connectivity was specified, so this concludes Step 1. Step 2 was how many servo axes and what type. Several choices are available for the 8 Mechatrolling 2 axes. A Sigma 2 SGDH amplifier with the NS115 Mechatrolling 2 interface card is a good choice, especially for larger amplifier capacities. The Sigma 3 SGDS Mechatrolling 2 network amplifier also works well, offering a few more position mode features and a smaller footprint, but lacking the digital operator panel, analog input capability, and range of power and voltage that the SGDH offers. Whatever the combination, these servos will occupy nodes 1 through 8 on the built-in Mechatrolling master. The servo axes with analog control will require the SVA analog motion module. Step 3 is I/O. Considering the high number of I/O points, the best choice is Mechatrolling I/O modules. The IO2310 handles 64 input and output points. 3 of these modules will be required, occupying nodes 9 through 11 on the built-in Mechatrolling network. Finally, the AN2910 analog output module can be used for the analog outputs, making it the 12th node. Another option would be to install a second SVA analog motion module in the remaining slot and use those analog outputs to control the inverter. This application could also be solved using the MP2200 base unit with a CPU module, Ethernet module, Mechatrolling master, and SVA module, leaving several slots available for further expansion. This concludes the eLearning module MP2000 hardware specifications. For more information, please contact us using any of the methods listed below.